Hello everyone, welcome back to our channel. Let's discuss the next topic, the group frequencies of organic compounds. The first type of compounds are what? Alkanes and cycloalkanes. So in alkanes and cycloalkanes, what kind of bonds we are observing? Carbon-carbon bond and carbon-hydrogen bond. Right? Already we had a discussion in the previous video. The stretching frequencies are very important than comparing with the bending frequencies. That's why in maximum times we are seeing the stretching frequencies only. In case of alkanes, we are having what? Carbon-carbon bond. The stretching frequency of the carbon-carbon single bond is in between 1000 to 1250. Similarly, we are having what? Carbon-hydrogen single bond. There also we can observe the stretching vibrations. The frequency of the stretching vibration is just below the 3000 centimeter inverse. In case of alkenes, we are having what? Carbon-carbon double bond and carbon-hydrogen single bond. So carbon-carbon double bond stretching frequency is in between 1500 to 1600 centimeter inverse. In case of alkenes, this one is what? sp3ch. But in case of alkenes, this is sp2ch or not. So in this case we are observing 3000 to 3100 centimeter inverse. In case of alkynes, what we are having? We are having C triple bond C and carbon hydrogen single bond. So the C triple bond C stretching frequency is what? 2100 to 2350 centimeter inverse. This is what? SPCH or not? It is around 3300 centimeter inverse. If you observe the carbon-carbon single bond, carbon-carbon double bond and carbon-carbon triple bond, what we are observing? It is around 1000, 1500 and 2100. It means that what? The stretching frequencies of the alkynes are greater than the alkenes. Alkenes are greater than alkanes are not. Why? What is the reason? The reason we will discuss in the next video. Factors influencing on the vibrational frequencies. There you are going to get the complete information why the stretching frequencies are more for some bonds and why the stretching frequencies are less for other bonds. Okay. Next. In case of alkanes, alkenes, alkynes, the bending frequencies are around 1000, in between 900 to 1000 only. In case of aromatic compounds, we are having benzene or not. In benzene, what we are observing? Carbon-carbon double bond and what? Carbon-hydrogen single bond or not. So, the range is what? 1440 to 1680 centimeter inverse. But in case of the benzene, we are observing 4 different peaks. The peaks are 1600, 1580, 1500 and 1450 centimeter inverse. In most of the cases, we are getting 4 different peaks whenever the benzene ring is present in the compound. See this one, the CH stretching is similar to alkenes or not? That's why the values are also similar to what? Alkenes and C double bond H in aromatic compounds. In case of this CH bending, here the bending vibrations plays very important role. Why? Because we are having mono-substituted, di-substituted benzenes or not. In order to identify the mono and di-substitution, the bending frequencies can be very useful. See this one. In case of the mono-substituted benzene, we are getting 2 peaks, bending peaks. In case of di-substituted benzene, the di-substitution may be ortho di-substitution, meta di-substitution or para di-substitution. So in such cases, what will be the frequency of this CH bending? See this one. In case of the ortho, we are getting only 1 peak. In case of meta, we are getting 2 peaks. In case of para, we are getting 1 peak in these regions. So in this way, we can easily identify whether the aromatic compound containing mono-substitution or di-substitution by using the what? CH bending vibrations. Now come to the next one, ethers. What is the general representation of ether? ROR or not? So here we are observing what? Carbon, oxygen, carbon bond or not? So the stretching frequency of this particular bond is in between 1000 to 1250. After that, if you see the R, it is a carbon chain or not? So the carbon chain is related to what? Alkanes or not? That's why the CH stretching frequency value is similar to what? Alkanes. Around 3000 centimeter inverse. In case of alcohols, what is the main bond? OH bond or not? So the OH stretching frequency is 3400 to 3600. There is a possibility for the hydrogen bonding in case of alcohols. So in case of alcohols, we are observing primary CO, secondary CO and tertiary CO. For all these, we are having values 1000, 1050 and 1100 centimeter inverse. In case of aromatic ethers, so we are going to have CO bond or not? The stretching frequency of that CO bond is greater than 1200 centimeter inverse. So this is about the what? Alcohols. Next one is what? Aldehydes. In case of the aldehydes, what is the main peak? The main peak is due to the carbon oxygen double bond, right? The carbon oxygen double bond is appear in between what? 1720 to 1740 centimeter inverse. In case of aldehydes, along with the CO, we are having what? Carbon hydrogen bond or not? That's why we are going to have carbon hydrogen stretching. This value is approximately 2800 centimeter inverse. Along with the C double bond O and CH stretching frequencies, we are going to observe different kinds of bonds. Those are what? Fermi resonance bonds or Fermi resonance peaks. Okay, this concept we will discuss in the types of peaks in IR spectroscopy. Okay, the next one is what? Ketone. In case of ketone also, the main one is what? Carbonyl group or not? So the carbonyl stretching frequency is 1705 to 1725. It means that what? Lesser than the aldehyde or not. So there is some influence of these R groups on this C. Okay. Next, carboxylic acids. In case of carboxylic acids, we are having what? Initially C double bond O group, C double bond O stretching, and also we are having what? OH stretching or not? The OH stretching is 3100 to 3700 centimeter inverse. In case of esters, the main is what? C double bond O 1730 to 1780. Along with that one, we are going to have CO stretching also. The CO stretching in the esters are similar to what in case of ethers, right? The next one is what? Amides. In amides, what we are observing? Main C double bond O, later NH. So NH value, C double bond O value. In case of the primary amides, we are having one bending bond, that is NH bending 1550 to 1650 centimeter inverse. In case of secondary amines, NH stretching is around 3000, NH bending is 1000. In case of tertiary, here there is no hydrogen. That's why there is no NH stretching, no peak above the 3000 centimeter. It means that what? We can distinguish primary, secondary, tertiary amines by using the IR spectroscopy. We can also distinguish primary, secondary, tertiary alcohols also. Okay. Then in case of acid halides, in acid halides also we are having which bond? C double bond O bond is the main bond or not? So C double bond O stretching frequency, then we are having CX bond. The CX stretching values will be 1000 centimeter inverse. So why? Because the X is the higher mass, chlorine, bromine, iodine. The effects will discuss in the factors influencing the vibrational frequency. Next, anhydrides. In anhydrides, main one is what? C double bond O or not? C double bond O stretching. Later we are having what? COC bond. COC stretching will also appear. The anhydrides may be acyclic one or cyclic one. Especially in case of the anhydrides, we are having a look on symmetric stretching, asymmetric stretching. See this one, symmetric value, asymmetric value, symmetric value, asymmetric value in case of acyclic and cyclic. In case of acyclic, COC stretching is in between this one. In case of cyclic, COC stretching is in between 1200 to 1300 centimeter inwards. Next, amines. Amines, which bonds are main? NH bond and CN bond. The ratio or the values are in between what? 3200 to 3400 and 1000 to 1250 centimeter inwards. The next type is what? Nitriles. In nitriles, which bond is main bond? C triple bond N or not? So, C triple bond and stretching frequency is in between 2200 to 2300. In case of aromatic C triple bond N, the value is slightly reduced. In case of isonitriles, the value is 2100 to 2150 centimeter inwards. The next one is what? Nitro compounds. In nitro compounds, we are having nitro group or not. So nitrogen oxygen bond. So nitrogen oxygen stretching frequency is going to be symmetric and asymmetric. This is the symmetric value, this is the asymmetric value. Already we know that comparing with the symmetric, asymmetric value is always higher. Why? Because the unequal change in the bond length, right? In case of aromatic nitro compound, symmetric and asymmetric. Symmetric value this one, asymmetric value this one. Cumulated double bonds. We all know that isolated double bonds, conjugated double bonds and cumulated double bonds. In case of the cumulated double bonds, the value is higher. That is appear at 1900 to 2000 centimeter inwards. So these are the values each and every aspirant should remember. Only the ranges. Depending upon the range, we can easily identify or we can easily distinguish different kinds of the organic compounds. So this is the concept of what the stretching and bending frequencies of different kinds of bonds which are present in the different organic functional groups.